Beads are, in general, a very nice tool in different aspects. So it starts with purification, and then you have all kinds of bead-based assays. And what's great about them is that they have a pretty easy to handle. And the way that we use beads is always in combination with a special kind of microplate, which allows us to run a bead-based assay or a reaction on a bead and then separate the beads kind of automatically by sedimentation and read out with a normal plate reader. In the best case, have the results for 384 samples. That's in terms of throughput. This is really, I guess, unmatched.
Hey, smart scientists. Welcome to another episode on the Smart Biotech Scientist podcast. Are you looking for a screening technology platform to determine critical parameters? Today, we're talking about that with Sebastian Giehring, who is the CEO and founder of PAIA Biotech, an innovative leader in bead-based assays. Stay tuned. Are you juggling the complexities of CMC development while trying to enjoy the beauty of biotech? Have you ever wondered if there's a way to simplify bioprocessing? Welcome to the Smart Biotech Scientist podcast, where we're diving headfirst into the very challenges you face. We're breaking it down, demystifying the jargon, and giving you the keys to unlock your full potential. I'm your host, David Brohlman, and I get it. With 15 plus years in the biotech industry, I face the same challenges you do. There's a way to simplify and streamline so you can remove complexity, you can skip trials and errors, deliver without delay your groundbreaking therapy to clinics and market, and still enjoy every single step. Do you want to learn how industry experts and I did it? Grab a cup of coffee and your favorite notebook and pen. Now is the time to take your bioprocessing game to the next level. Let's smarten up biotech. Welcome, Sebastian, on the Smart Biotech Scientist podcast.
Thanks, David. Thanks for having me.
Absolutely. It's a pleasure having you on. Sebastian, share something that most people don't know about you.
Well, maybe that I'm a passionate chess player. That's something I discovered back in my school days, and I guess that's what I'm going to be doing until the end of my life, basically. So whenever I have a little bit of free time besides job and family, I like to play some online games or to watch the top tournaments. This is really a nice way for me to relax and also be entertained. So really cool stuff going on there.
And what inspired you to pursue a career in biotech, and what have been some of the most rewarding moments in your work as the CEO of PAIA Biotech?
This could be a long answer. I guess many people that ended up being in biotech don't think about this at the beginning of their career. So when I finished my PhD in the university, I couldn't have imagined that I have a career later in biotech. So I worked in a company for analytical equipment. And then after some years, I completely changed. I had the opportunity to join a venture capital company that dealt with life science. That was in the early 2000s. And this is how I really tapped into life science biotech. I saw a lot of different companies, which I found really exciting. It was a great opportunity to discover a lot of things. But what was a little frustrating was that we didn't have back then a lot of money to spend and to invest in companies because we had to keep our existing portfolio afloat, more or less. And the other thing which I learned, that I was someone who needed to be able to be actively involved in a company. As an investor, you're kind of keeping a certain distance and there's not a lot you can do to help companies. So this is what kind of inspired me or to have a look at whether I can be involved in startup and in the biotech sector. And that's what I finally did. Now this is my third. PAIA Biotech is my third startup company, which kind of evolved from the ones I was involved before that. And yeah, this is how I ended up being a CEO of PAIA Biotech now. So that's it. And when it comes to rewards, that's your second question. if you're working in a smaller company, there are a lot of things that you do, right? So reward comes in a lot of different flavors, I would say. So it can be a great idea for a new assay. It can be a patent that is granted. It can be great feedback from customers who like your products and appreciate it. It can be building the team and putting people into roles in which they thrive. So that's a lot of different things which are really rewarding. So a lot of stuff that also compensates for the not so fun stuff that also, of course, exists.
Can you briefly introduce your company, PAIA, and the solutions that you provide?
We've been around for 10 years now. And when we founded the company in 2014, what we had is a platform technology. It was a technology that maybe we'll talk a bit in more detail later on. That we knew was kind of broadly applicable. And we had only kind of an idea what kind of solutions we wanted to provide with this technology. So we had to find the applications, and we went on to first launch titer assays for cell and development, bioprocess development, etc. Then went on to develop glycan assays and more critical quality attribute related assays for aggregation, for mispairing, etc., etc. So really expanded the portfolio, all based on this special kind of detection technology. And most recently, and this is very exciting, we also discovered new applications in the antibody discovery field, which is entirely new to us and very exciting. That's a very much emerging application these days, and we've made a lot of progress there.
Starting a company sounds like a lot of fun to me. It's exciting, but there's a big but. There are also a lot of challenges. Can you tell us what the toughest challenges in building your company?
I kind of mentioned this already, is that you have to come from at least in our case, starting with the technology is great. And you can potentially do a lot of things with it, but then to really find the applications that are really beneficial for customers. So we started, and then we had to find new applications and develop new assays for them as we went along the way. So starting with titer and then the other assays afterwards. That's one challenge, that you need to stay innovative and expand your portfolio. And then, of course, you have to convince your customers that it's worth implementing these technologies. And if you only have one assay, of course, well, maybe it's not worth the effort if you see it from the customer perspective. So if you have more to offer than only one assay, that's a big plus, obviously. So then supporting customers and make sure that all these assays work well in the hands of the customer is important. And then you also come to realize that people don't have a lot of time, like in parallel to their normal workload, to really evaluate new technology, etc. So you really need to make sure that it's as easy as possible for people to implement these new assays. And also we had to realize that people that work in cell culture and cell line development, etc., are not analytical people. So this is usually a task that is performed in analytical departments. So somewhere in between, and you have to convince people on one hand side to take on additional tasks. And then you also have to convince analytical guys the assays and the technology that we provide and the results that we can achieve are really worth it, and that they accept methods which are not like MS or chromatography, what everybody is relying on usually. So what we have been doing in the last years also is seeking cooperations with larger companies, equipment manufacturers who want to integrate assays like ours in their integrated workflows. There are now 2 partnerships going on with Cytina, with Advanced Instruments. So they run our assays on their machines, and this is an integrated workflow with the software to evaluate the assays and then also store the data in a way that allows people to kind of seamlessly integrate our assays into their workflows. That's the ongoing challenges that we're facing, but I think this integration is really key also for more assays to come.
Yeah, it's great to see that you have been innovating so much. I remember the early days when we had the opportunity to actually collaborate, where we were able to test some of your kits and just to see where you are now as a company. This is really exciting. And Let's delve into the more technical parts of your assay, because bead-based assays have become a key tool in developability screening, also in process development. Sebastian, can you explain what bead-based assays are and how they work?
Beads are, in general, a very nice tool in different aspects. So it starts with purification, and then you have all kinds of bead-based assays. I mean, it's, if you take FACS, for example, etc., etc. So they come in different kinds of flavors, different sizes. And what's great about them is that they have a pretty easy to handle. I mean, I'm not talking about magnetic beads at the moment, but they are easy to handle and they are nice and easy to functionalize, and they offer a big surface. And the way that we use beads is always in combination with a special kind of microplate, which allows us to run a bead-based assay or a reaction on a bead and then separate the beads kind of automatically by sedimentation and read out with a normal plate reader. So basically, the components that we use is the beads and then kind of reagents which you know from normal immunoassays, like from ELISA, etc. So you have some kind of a detection molecule that binds in a kind of sandwich format, for example, the antibody that you want to analyze. And the great thing is that you only need this plate, which comes already with the beads on it. You add your sample and the reagent shake for a certain time, like half an hour, and then in the best case have the results for 384 samples. That's in terms of throughput. This is really, I guess, unmatched.
So how does this work practically? Let's say I want to analyze different quality attributes like glycosylation, aggregation, perhaps titer. Do I need to use different plates and then prepare them differently, or is it the same plate? How does that work?
The plate is always the same type of plate, but of course, depending on the application, we're using a different combination of beads and detection molecule. For example, if we talk about the glycan assay, we're using beads that bind the antibody. And once the antibody is bound, we detect the glycans on the antibody with lectins, which carry a fluorescence tag. And those lectins are proteins that specifically bind to different types of sugars, which are present on the glycans on the antibody. And this kind of principle we use in different ways for the other assays as well. It's basically only, so to say, to find the right combination of functionalization on the beads and the right detection molecules to make the assays work.
And what are the advantages of bead-based assays over traditional high-throughput screening technologies?
I think it's the speed and the ease of operation. In the end, it's only 2 dispensing steps that you have to perform. You add your sample to the well and you add the reagent to it and shake, and that's it basically. And then for each of the wells, you just get a fluorescence intensity, which tells you is there binding, yes or no, and how much it is. Of course, what you also need to do if you want to derive some quantitative or semi-quantitative information, you need to have standards. You have to run some material with it that you know what, for example, the amount of glycosylation or malosylation or galactosylation is, or aggregation if we're talking about aggregation. It's pretty easy, but we also have to say that this is a screening method. So it means that if you compare, for example, the glycan screening assay to methods like HPLC or MS, that information that you get from these assays is less detailed, but it's the application scenario is also different. You want to be able to measure a lot of samples in the early stages of process development to be able to eliminate either bad cell lines or unfavorable cell culture conditions and move on faster than what you were able to do previously if you had only a smaller number of samples that you could get analyzed, for example, in the analytics department, for which you had to usually wait for 3-4 weeks before you got results back and then move on.
Yeah, absolutely. I think that's something to keep in mind, smart biotech scientists. We need assays where we can test a lot of different conditions quickly, and at that stage, so early in the development cycle, we're not so much interested in getting the best resolution. It's more about the quantity of samples in a quick time in order to make decisions like what is the best cell line, for instance, or which is the best producer, or where do we have the right quality attributes. Now, can you give us a quick overview on the quality attributes we can easily measure using a bead-based assay, so both in process development and in an early developability assay? And are there any quality attributes we can't currently measure with this technology?
Wow, okay. This is a complicated question. So first, looking at quality attributes maybe in early process development, then I would say, okay, glycosylation, you can do it. This is not a big problem, but we know that glycosylation, cell culture and how it influences glycosylation is a really tricky thing. Right? It can change over time. It can change with the cell culture conditions. It can change depending on the cell line, etc., etc. And then if you want to look at it at different stages of the cell culture upscaling process, I mean, you know that a lot better than I from your experience, how challenging this is. So there are a lot of other challenges involved. And if it comes to aggregation, for example, the benchmark method is, of course, size exclusion chromatography there. So it's limited in terms of throughput. You can measure aggregation very well with this method, but you also need to purify samples before, and you know that purification is also impacting aggregation, potentially at least. And then you also know that SEC does not capture all the aggregates that may be present in the sample. So if we're looking about big aggregates, they are lost on the column, so you don't see that. The question is, how important is that? It's really challenging. And then if you think that nowadays in most process developments, you're not dealing with normal antibodies, but with more complex molecules like bispecifics or some crazy multispecifics, then things get a lot more messy. Then you're talking about mispaired constructs, etc., etc. And this is really, I guess, a very difficult task. We have a mispairing assay available, which is basically trying to bring a CEX, cation exchange chromatography approach into a microplate, which is a very cool idea, but it's of course limited in terms of resolution. So if the mixtures are getting really wild, I guess it's better to do CEX or MS, etc., etc. So there's still a lot of challenges ahead, and these complex molecules, I guess, are really tough to deal with.
Hey, smart biotech scientists. I hope you've been enjoying our conversation with Sebastian Giehring, who's the CEO and founder of PAIA Biotech, an innovative leader in bead-based assays. What do you think of today's episode? Please tell us by leaving a review. And perhaps you are in the middle of setting up your screening technology platform, but you're not so sure how to set up your experiments and how to get the most out of your experimental design. Well, if this is you, I want to help you get clarity and to help you get started on the right foot. So I'm offering you a free, no strings attached assessment. Just book your free call using the links down in the show notes, and I'll see you on the call. All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. If you enjoyed this episode, please leave a review on Apple Podcasts or your favorite podcast platform. By doing so, we can empower more scientists like you. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.